Hello guys, in this video we are going to discuss the solution of the problem reach a given score. So let us look at the problem statement. So the problem statement says that consider a game where a player can score 3 or 5 or 10 in a move. Given a total score n, find number of distinct combinations to reach the given score. So for instance, in this example, n is given as 10, and to reach n there are two ways possible, and these are those two ways. And since there are two ways possible, that is why we are going to return 2. Whereas in this example where n equals to 20, there are 4 distinct ways by which we will be able to reach 20. And these are those 4 distinct ways, because of which we are returning 4. Okay, so that's about the problem statement, folks. Now let us see how we will be able to solve this problem. So in order to solve this problem, so let's take an example. So let us say n is equals to n is equals to 10. So for this, we will need a DP table of size n plus 1. Okay, and the initial value for all the element will be 0, and DP of 0 we are going to set it as 1, as 0 is reachable nonetheless. So now let's create a DP table for this. So this is the DP table we have, and DP of 0, let us make it 1, and all other entries are 0. Now we are going to update the entries. So what we are going to do is we are going to iterate on for I in range 3 to n plus 1. Okay, so we are going to iterate from 3 to n plus 1, and we are going to see whether ith is reachable from whether ith is reachable via making a move of 3. Okay, making a move of 3. So the way we can do it is, well, what we are going to do is dp of I will be equals to dp of I plus dp of I minus 3. Okay, so let us go through an example in order to understand it. So I is equals to 3, we are at third location. Now whether we will be able to reach 3 via making a move of 3 or not. So what I am doing is, so let us say we make a move of 3. So once we make a move of 3, then the remainder what we have is 0. Okay, and now what I am checking here is whether dp of 0 is reachable or not. And since dp of 0 equals to 1, so it is reachable. That is why if you put the values, or if you plug the values in this equation, you will get dp of 3 equals to 1. Okay, similarly, if you look for dp of 4, so dp of 4 will be equals to dp of 4 plus dp of 1, and dp of 1 is equals to 0. dp of 4, the default value is 0, so this is 0 plus 0, which simply means 4 is not reachable via making a move of 3, which is what it should be, right? So if you make a move of 3, then you will be left with 1. There is no way while we will be able to move to 0 by making a move of 3. Okay, so that is why this will be equals to 0. Moving forward, this again will be equals to 0. dp of 6 again will be reachable, because 6, if you see, this becomes dp of 6 plus dp of 3, and dp of 3 is 1, so that is why this will be equals to 1. Similarly, these two values will be 0, and dp of 9 again will be equals to 1, and this will be 0. So this is how we will be able to populate it if a given I is reachable from 3 or not, or if I is reachable via making a move of 3. The same thing which we are going to do for 5 also. So what we are going to do is for I in range 3 to n plus 1, and here we are going to check whether a given entry is reachable via making a move of 5 or not. So this is something which we are going to populate it. Sorry, this will be 5 plus dp of I minus 5. So let's look at that. Now let's plug the values. So we will start from 1. We will start from 5. So this will become reachable. So this will become 1. This again, the value will still be intact here. So let's work with 6 in order to understand it. So dp of 6 will be equals to dp of 6 plus dp of 1. So dp of 6 is equals to 1 and dp of 1 is equals to 0, because of which this becomes 0, or this remains 1. I'm sorry, this remains 1. So that is what we are maintaining. Now let's look for dp of 7. So dp of 7 will be equals to dp of 7 plus dp of 2. dp of 7 is equals to 0 and dp of 2 is equals to 0. So this remains 0. So we are going to maintain the entry of 0. Now let's look at dp of 8. dp of 8 is equals to dp of 8 plus dp of 3. And this becomes dp of 8 is 0 and dp of 3 is reachable via 3. We have populated that value. So this becomes 1, and because of which this becomes 1. So because of which this becomes equals to 1. 9 will remains, so the ninth entry will remain as it is, whereas this entry we will make it as 1. Since this becomes dp of 10 plus dp of 5, which 5 is reachable, so this becomes 1. Similarly, we are going to do it for 10 also. So for 10, again we will have a for loop for I in range 10 to n plus 1. And we are going to update in the same way, which is dp of I is equals to dp of I plus dp of I minus 10. So if you see here, this I minus 1, which is this, right? So this will start from here, and this entry will be updated by 2. And towards the end, we are going to return dp of n. Okay. So that's about the explanation, folks. Now let us see how we will be able to code this out. So the code is this. So we have a dp table and the default value is 0. dp of 0 we have set it to 1. So we are iterating the dp table for 3 times. If it is reachable via making a move of 3, we are setting it to 1, or we are increasing the value there. Similarly for 5 and 10, and towards the end we are going to go ahead and return dp of n. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any comment or question regarding this video, please feel free to use the comment section and I will try to address them. Thank you.